I am Mini from EC department at Emmanuel Arthur JJ College of Engineering. Convert the given block diagram shown in figure into signal flow graph and determine the closed loop transfer function C of S by R of S. This problem is taken from the topic signal flow graph in control system. This is the block diagram. First we have to convert this block diagram into signal flow graph. For that, initially we assign the nodes at input, output and at every summing point as well as the branch point. This is the input. We consider this as node 1. This is the summing point. We take this as node 2 and this is the takeoff point. We take this as node 3 and this is another takeoff point which is node 4. This is another summing point, that is node 5, and the output is node 6. Next, we assign the values. How will you assign the values? Between 1 and 2, nothing is there, so we consider that as 1. Between 2 and 3, here also there is no value, so we consider that value also 1. But between 3 and 4, the value is G1, so take this as G1. Between 4 and 5, the value is G2, write that G2 value. Between 5 and 6, here also there is no value, so instead of that, we will write 1. From between 3 and 5, the value is G3, but it reaches with a negative sign, so we will write the value as minus G3. Between 2 and 4, the value is H with a negative sign, so minus H. Next, we move to the step 1, that is forward path gain. We will represent the forward path gain as K. In this problem, there is 2 forward path. How will you find that forward path? Forward path means from starting to ending, there is only one way, but not backward. Here, this is the first forward path, 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 6. There is no backward arrow. It starts from node 1, ends with node 6. So, we consider this as a forward path 1. Is there is any other forward path? Check it. 1 to 2, 2 to 3, this is the another path, 3 to 5 and 5 to 6. Here also the arrow is towards only, there is no backward. So this is also another one forward path. Then if you are considering this way, 1 to 2, 2 to 4, but this arrow is backwards, so this is not a forward path. So this problem, only 2 forward paths are there, so K is equal to 2. Now we need the values for that forward path. The first forward path is P1 and the second forward path is P2. We separately redrawn this diagram. So this is the diagram, forward path 1 and forward path 2. How will you find the values? We had the values which is present on the nodes. Here 1, 1, G1, G2, 1. Multiply all the values. P1 is equal to, substitute, multiply the values and write the answer. Then what about forward path 2? Here also so many values are present above the nodes. 1, 1, minus G3, 1. If you are multiplying all the values, we get P2 is equal to minus G3. Next we move to the step 2, that is individual loop gain. We know that what is meant by loop? Starting and ending points are same node. So, see the diagram. Here, if you are considering this as a node, the starting point 3, but the ending point is not 3. But instead of this, here the ending point is 5. So, this is not a loop. So, if you are considering this as a loop, it starts from 2. Again, it ends also 2. So, it starts from 2 and travel towards 3 and it finally returns back to 2. So, this is a loop. So, here in this problem, only one loop is there. So we will separately redraw this diagram. We consider that gain as P11. The value is, that is 1 into G1 into minus H. That is minus G1 into H. Next we move to next step, that is step 3. Here the gain products of two non-touching loops. What is that is non-touching loops? Here we consider that as here there is no combination of non-touching loops because here only one loop is there. There is no two non-touching loops. Then therefore we skip this and move to the next step, step 4. We have to calculate del and del k. We know that k is the forward path. And how will you find del? The formula is 1 minus P11. We know that P11 is the individual loop gain. In this problem, only one individual loop gain. So we have P11 alone. But if we have more number of individual loops, we take that as P12, P13, etc. Here, no need to take that because only one individual loop gain is there. So 1 minus P11. And how will you find del 1 and del 2? We know that del k, suffix k is the forward path. In this problem, the value of k is 2. So del 1 and del 2, which becomes 1. Why this value is 1? Because we have two forward path. Both forward path have loops. Therefore, we represent that as 1. Finally, we will find the transfer function. How will you find the transfer function? Using Mason's gain formula. The formula is T is equal to 1 by del into summation over k, pk into del k. Substitute the values. So P1 into del 1 plus P2 into del 2. The value of P1 is this and the value of del 1 is this. Again, value of P2 is here and the value of del 2 is here. Substitute all the values. We get the answer T is equal to G1 G2 minus G3 divided by 1 plus G1 into H. This is the overall transfer function C of S by R of S. Thank you.